The Sieve of Eratosthenes, named after its inventor, the Greek scholar Eratosthenes, from 276 to 194 BCE, provides a way to find all prime numbers less than or equal to some fixed number n. To construct it, write out all the integers from 2 to n, cross out all multiples of 2 except 2 itself, then all multiples of 3 except 3 itself, then all multiples of 5 except 5 itself, and so forth. Continue crossing out the multiples of each successive prime number up to the square root of n. The numbers that are not crossed out are all the prime numbers from 2 to n. Here is a sieve of Eratosthenes that includes the numbers from 2 to 27. The multiples of 2 are crossed off with a forward slash, the multiples of 3 with a backslash, and the multiples of 5 with a horizontal slash. Use the sieve of Eratosthenes to find all prime numbers less than 100. So we start by ignoring 1. The first prime number is 2. And so what we're going to do is we're going to cross off every single integer in this list that's divisible by 2, except for 2 itself. This part of the sieve is the slowest part because there are a lot of even integers up to 100. And this kind of shows that most integers in lists from 1 to n are not prime. Okay, so we've gotten rid of all of the numbers that are divisible by 2. Next, we're going to circle the next number that's not crossed off, and we're going to cross out every multiple of that number. So now we have to cross off every multiple of 3 except 3 itself. We already crossed off 6, so we can go to 9, 15, and so on. Okay, the next number that's not crossed off, we circle that, and that number is a prime number, which is 5. So now we have to cross out all the multiples of 5. That's pretty easy. The next number that's not crossed out is 7. That's a prime number. Now let's get rid of all the multiples of 7. The first multiple of 7 that we haven't crossed off yet is 49, and then 77, and then 91. Now, if you notice, once we reach 10, 10 is the square root of 100. And according to the directions, we have to continue crossing out the multiples of each successive prime up to the square root of n. In this case, n is 100, so the square root of n is 10. We're about to pass 10 and go on to 11, which means that all of the numbers that are not crossed off are prime numbers. And we don't have to check for multiples of these prime numbers because we can be sure that those multiples are already crossed off. And so this moment really reveals a lot of prime numbers in this list. And these are your prime numbers. Thanks everyone, and I'll see you in the next video.